Okay, so the last part here, we want to look at calculating angles from ratios on the calculator, which we just did, and most of you know how to do this, but we also want to be able to write the notation of this. Okay, so we have, when we ever want to solve for angles, oops, what happened there? If I want to solve for my angle, okay, I have a ratio, sine x equals 0.5, that's a ratio. X is an angle. So I need to make sure that I want to find the angle, so I'm going to use the opposite, which is arc sine, and I'm going to write it like this. So this is what we're going to start working on. I want to be able to write the arc sine form of this, okay? So or the inverse form. So the inverse form of this is going to look like this: arc sine 0.5, the arc sine of the ratio equals angle x. Okay. So here, if I have cosine x equals y, we need to be very clear which is the angle, which is the ratio. X is my angle, y is my ratio. 0.5 is the ratio. We put ratios into arc sine. Sines equal the ratio. Arc sines equal the angle. So here, the y is my ratio, x is my angle. Okay? My input is angle, output is ratio. Here my input is ratio, output is angle. Okay, same thing here. X is my angle, y is my ratio. I do arc sine of the ratio, gives me angle. Okay, so when I'm given these ratios, I want you to be able to write the arc sine form. So the arc sine form looks like this. The inverse form, the arc sine is going to be of 0.120 equals x. Then I can solve this. Okay, so that is not a special angle, so I need my calculator. And I get an angle of 0.12. The angle x is approximately equal to 0.12 radians. Now this is where we have to start becoming much more careful with radians, because the sine ratio, that's a ratio, 0.120 is a ratio. This 0.12 is very similar. In fact, that's nice. There's a very useful property of that we use in calculus. But they are similar. One is a ratio, one represents an angle or length. Okay, in this case, it's a length on the circumference. And we have to be careful because they look the same. So what I'm going to do is I'm going to generally write the ratios with 3 decimals, angles with 2. And that helps us kind of visually identify it, but we really should know the difference when we're dealing with angles and ratios. And we should take a minute to make sure we're clear on that before we do problems. Okay, so again here, this 1/2 represents a ratio, so I'm going to write the arc cos form. X is my angle. Okay, this is a special ratio, so we shouldn't be using a calculator for this. We know that theta 1/2, that's going to be 60 degrees. Okay, so x is going to be, in radians, is going to be pi over 3. I forgot about here too that we have theta 2. Okay, so when we talk about, there's theta 1, theta 2 is over here. So theta 2 is going to be 180 or pi. We're going to go backwards the same amount here. Okay, that's approximately 3.02 radians. Here, theta 2 is going to be, the symmetry for cosine is down here, so that theta 2 angle should be negative pi over 3. Okay, which we can also say is equal to 5 pi over 3. Okay, those are actually equivalent. Those are coterminal angles. This is good enough though. Tan equals 1. Okay, so first of all, write the arctan form. The slope is 1, the angle is x. If my slope is 1, my angle is 45 and 225. Okay, in radians, that's 1/4 of pi. That one's going to be 5/4 of pi. And the last one here, we're going to write again the arc sine form first. Negative 0.222. That's going to give my angle x. Arc sine being negative down to these two quadrants. Okay, so my angle x. This is not a special angle, so I need a calculator. I can't do this without a calculator. So I'm going to get 0.224. I'm just going to round that to 0.22. Negative. Is that negative? Yeah, negative 0.22 radians. Okay, so that's going to be this angle here in quadrant 4. So I want to find out the other angle in quadrant 3. So I'm going to do pi minus negative 0.2. I'm going to add 0.22 radians here. So I'm going to end up with 3.36 radians as my theta 2.